Welcome to the Demystify Technology podcast from the McLaren Group.
Typically, you go through the due diligence process. What the world of private equity?
Right. Can't wait. Demystify it.
It scales with you, it's easily manageable, and has incredible recovery capabilities, saving you time, money, and worry. Alan and Ryan discuss Aurora, the MySQL and Postgres compatible database as a service from Amazon AWS, which has done wonders for managing and scaling databases in production.
Ryan, we're here.
Good morning. How are you?
I'd like to think you're beside me, but I know I can't touch you.
I hopefully I'm looking in the right direction at the moment.
Yeah,
for
me too.
For sake of the episode.
But our editing wizard Caitlin will make us look great, I hope. So we're here today, as we're all working safely from home, to discuss and to go through some of the wonders of Aurora.
Yeah, wonderful database technology put out by AWS. We've been using it for a number of years with great success, so kind of excited to share what we've learned along the way.
Yes, and Aurora, for those that don't know, is effectively the database as a service. That's where AWS manages, and for us, we've been using the MySQL flavor of it, although Postgres is available, to use that as our production-based systems for our clients, and to automatically have failover and read-write clusters and read-only clusters. All the hassles that you used to have with MySQL, master slave, and all those different type of replication issues you had, all gone. It's absolutely wonderful. So, Ryan,
yeah.
what have we used, and why have we used it?
So there's a number of features that are available. So I guess in terms of like a high-level list of some of the things we can cover, first would be kind of to your point, the failover mechanism. So the concept of having these master nodes and read replicas and then automatically fail over, that sort of stuff. So kind of effectively getting you fault tolerance, right? Another one would be they have a relatively new feature called Backtrack, which kind of allows you to rewind your database, which is fascinating. They have the concept of point-in-time recovery, which when I say point-in-time, I mean literally you can restore a database to a particular second, which is fascinating. And then I would say one of the other kind of big ones would be Performance Insights, which I think that's independent of Aurora, but Performance Insights is a cool one that allows you to look into what load is going onto your database and which queries are kind of slowing you down. There's probably some other ones that I'll come up with as we go along. But
okay, so let's start to begin with. So spinning up RDS Aurora, you're not really managing a server, are you? But you still have to decide which instance type you're going for.
Yeah, so it's very much kind of if you're familiar with EC2 or just kind of virtualization in general, you kind of choose it when you start off. You just choose your instance type, right? So then the main thing you're concerned at that point is how much CPU do you want and how much memory do you want. To that end, they do have support for the burstable instances, which is quite handy. Those tend to allow you, especially when you're in development mode, or you're just running you're just starting out and launching your product where you don't need a big honking database with a lot of memory. You just need kind of the bare minimum that'll get you going. So yeah, when you go to launch it, you just got to choose kind of what flavor of Aurora do you want to go with? Do you want MySQL? Do you want Postgres? What's your instance type? And then just a couple other configuration parameters, and then you're kind of off to the races. You don't have to worry about all this kind of interconnecting or actually provisioning the box or any of that sort of stuff. That's just all done behind the scenes.
And you don't get SSH access to these boxes. These are closed boxes, so it's not a traditional EC2 instance where you can go behind the scenes and start fiddling.
Yeah, no, and I think that's an important distinction when you start looking at AWS services, whether or not the service is launching itself as what they call a fully managed service. Fully managed services, basically, they are taking all the kind of administrative burden onto them. So generally, you pay a little bit more because they're of course charging for that ability to take on that, for in this case, the database administration task. But generally, it's well worth it because you don't have to pay for, or you don't need quite as highly skilled of a DB admin or something like that, because all those more complex things just get offloaded to AWS. But yeah, no, you don't get direct access. You still get a master login account to the database, so you can still kind of go in and create your own permissions, create your tables, do all of that sort of stuff. But the underlying server hardware, you don't get to touch that at all.
Yeah, and many of the configuration settings that you would normally tweak with MySQL, you only get the ones that are available through effectively port 3306 to keep it simple. You don't get to tweak the CNF file underneath the covers.
No. I mean, and they do make the ability, they do provide the ability to export the audit logs if you want to be able to kind of like truly output all the queries that are running against it. The general log, the slow query log, and the error log. Those 4 log types can be exported out to where you can still see that log data coming out in case you want it for auditing purposes or just debugging, that sort of thing.
So in development, we'd spin up a normal Aurora box, but to all intended purposes, it's just a MySQL box because we wouldn't turn on clustering or anything like that in development because there's no point, and we can stomach downtime in development, etc. That's no problems. Where Aurora really kicks in is when we go to production. So when we spin up a cluster, what are we meaning by that, and what do we get?
Yeah, so this would be kind of that first point I talked about, which is the concept of kind of failover. And so what it allows you to do is very easily create these nodes called, they call them read replicas. It's a common database terminology, which is effectively, it's just literally that. It's a read-only node. So you'll have your primary node, which is the one that allows writes to occur. So it can do both reads and writes to the database. However, you can then start spinning up read replicas that are connected behind it. And so there's generally a little bit of replica lag,
and you see that in the console. It'll tell you how many milliseconds behind. It's usually like 10 to 20.
And honestly, it's very rare that you see beyond 20 unless you're just dumping a lot of data in very quickly. And that's, I think, part of the black magic in terms of how Aurora operates. So another one of those cool things with Aurora that comes into play here is it hasn't kind of an independent disk system. And what I mean by that is most traditional databases, even in the rest of the RDS service, like if you launched a just normal MySQL box in RDS, you would still have to say, hey, I want to provision a 50 gig hard drive for this thing. And then as your data grow over time, you'd have to say, oh, well, now I need to upscale that to 75 gigs or 100 gigs. And so there's kind of a process around that. Aurora doesn't have any of that. Aurora just is, you pay for how much disk space you're using, and the disk behind the scenes will just automatically grow with your data. And part of what they do is part of this replication. So in reality, what the read replica is doing is the read replica almost connects on and gets a view to that data as well. So it's not this concept like if you are a person that's a little bit more familiar with MySQL, it's not like it's replicating the bin log where it's kind of like literally kind of re-executing the queries behind the scene to another server. No, you're both looking at the same data set.
Yeah, and that's a wonderful distinction. We'll see that a little bit later on because you've got some beautiful graphs to show where historically, if you did, say, for example, a big, huge insert or an alter statement or something that would take the database a bit of time to do, you would see the peak in the master, and traditionally you would see the peaks in the slaves as they all executed that same bin log.
Yeah.
In Aurora RDS, you don't see that.
No.
And you'll see that in some of the graphs that you're going to show later on.
Yeah, and then the other cool thing it allows you to do, right, is it allows you to have multiple reads. So you can, if you design your system, because most systems you're going to be doing more reading against your database than writing. What you can then do is you can scale out your reads. So you can effectively have, say, one write node, but 10 reader nodes if you just have a lot of queries that are just kind of hitting it. And so it allows you to distribute your selects across more databases. And so that saves you generally money because with the way pricing works, generally if you have to go to a much bigger instance, the price jumps a lot quicker than if you just ran more smaller instances, right? The cloud model proves itself out again. And so when you get into this game of being able to do that, it allows you to also fail over quickly. So if your master has an issue, it can quickly detect that and say, all right, I'm promoting one of my read replicas to now become the new master. And it doesn't have to play that catch-up game, right? When it has to fail over, generally, I've rarely seen a failover take more than a minute. Generally, it's taking closer to somewhere in the neighborhood of 20 to 30 seconds. And that can do it that quickly, mainly because all it's really doing is it's got to bring a new one online and say, yep, I'm the new master, propagate that out. But it doesn't have to do this disk catch-up to say, oh, I need to catch up and execute these queries that I hadn't quite executed yet before I can become master.
Yeah, and we've seen that done a lot, and you'll talk about in a minute how you use that as a feature to scale up and to scale down in a managed way. Now, from the client side of the fence, and when I'm talking about the client, I'm talking about the Java app or the Lambda function, etc. You get two URLs, don't you?
Yeah. So effectively, you get the main URL, which would be points to writer nodes. So while I said you could scale out readers, they also recently, I want to say in the past year, they've added in the ability where you can also even scale up your write nodes as well. So this is a URL that will always point to the pool of writers, right? So if you need to make a write, this would be the URL you use. You can also use it for reads, but generally, if you need to write data, that's the one you want to use. They'll also provide you a second URL, which is the read-only URL, and that will point to the pool of read replicas. So effectively, you get two URLs, one to your write pool and one to your read pool.
And those are URLs that are resolved to a given machine inside of that pool. So it stands to sense that in these situations, you should not use connection pooling in your application.
No. You generally want to keep because especially if you're ever dealing with fault tolerance, that sort of stuff, you need to be kind of constantly redoing your connections, because one thing you don't want to do is have a connection that's long running that's connected to a node that's no longer the master, or vice versa. It used to be a reader, now it's that. So it needs to be kind of constantly cycling these connections. Generally, like I said, you can get some performance gains, right? I'm not saying you need to cycle it every 5-10 seconds, but you don't want these nice long running held connections, because that could cause you issues if you do ever have to fail.
Yeah, and the good thing with MySQL is that the actual the connection time is negligible these days. And while we talk about not doing pooling, we would pool on a per request level, as opposed to a pool across what you would historically say, okay, I'm having a pool of connections in, say, a Tomcat server, and that there'll be wrong running pools, etc. So now it's on a per request server on that respect. So as far as your application is concerned, you don't really have to worry about which one I'm talking to, as long as you've got it at a logical level that, yeah, this piece of code can in actual fact use data from the read-only server. Now, that read-only server may actually be talking to the write server if you've only got one machine in the cluster.
Yeah, generally, if you're in dev, right, even though it'll still provide you with the two URLs, the read URL and the write URL are going to point to the same thing, because you only have one instance, so it's just the writer. And to kind of that point of like your pooling and stuff, one other important distinction I would say here is, whatever you're using to connect, this technology and this kind of approach relies on DNS, right? So because we're pointing to that URL, behind the scenes, your library needs to be kind of constantly checking DNS to say, hey, has the DNS entries behind the scene changed? And that's another part that the RDS service is managing, is it's basically keeping up-to-date DNS to say, hey, yeah, this guy is now in this pool, so it'll start adding that. So if you were doing the NS lookup, the DNS lookup on your command line, you would basically see those IPs moving around inside the pool as failover happens.
Yeah, and you know, some earlier versions of Java were very aggressive in their caching of the DNS lookups, and you can tune that through command line switches, etc. But just be very conscious of that fact as well. So one of the features that you talked about, and we've utilized this a couple of times just for forensic purposes, as opposed to having to restore anything, is this point-in-time recovery. Now, this is just a beautiful, beautiful feature. It's like edit undo for a database.
And so actually this is where, so we've generally always used the point-in-time recovery. So you get point-in-time recovery with automatic, or what they call automated snapshots. So when you're creating the database, one of the options you'll get to configure is kind of how long of an automated snapshot window you want to configure. You get the first 24 hours free as just part of your bill. You have to pay extra for everything beyond that. But what it does get you is, if you run into a particular issue, you could then go and say, hey, Billy just executed a delete query that we didn't want him to execute, so he's deleted some data. We kind of need to get that data back. Well, as long as you have logging and all that sort of stuff, or even if you got like a rough ballpark, you can say, okay, well, we know Billy executed this at 5:45, or even down to the second at 5:45 with 30 seconds in. You can then go to Aurora, say, hey, restore me back using my automated snapshot to that point in time down to the second, and then it'll bring online a brand new database instance with your data at that point in time.
And that's a completely separate database. It's not going in your pool. It's a completely separate instance that's run up, and you're not being charged for that. But again, this is an emergency. You've spun up a machine. you can now do something with it and then kill it off at a later date. It's got nothing to do with the existing pool.
Yeah. Your other database would still be marching along like normal, collecting data and just operating in that state. And depending on the amount of data you have at play here, generally what I've seen with, now granted, we're not dealing with super large data sets, it usually takes in the neighborhood of 20 to 30 minutes to get that instance up and running to the point where you can actually connect to it and start getting data off of it. Because what you'll do then is you'll kind of have a little bit of a forensics go on where you'll have to say, okay, look at my current database and just find out what's missing. All right, now let me go over to the one that's been restored, do an export of that data, and then re-import it into my main cluster, and then do any.
Yeah, but that's more of a business decision as opposed to anything from the Aurora side of the fence. And you know, in the old days, this would be a plethora of MySQL scripts being run all over the place and moving files around and all that sort of nonsense. And it was a pain in the ass. This is just a point-and-click interface inside of the RDS command console.
Yeah, it'll just bring it brand new up, and to your point, once you're done with it and you've kind of gotten the data off of it that you need, you just throw it away and you stop paying. So in most of these cases, like doubtful you're going to be running these more for a couple hours, so it probably costs you less than like 50 cents in most cases, unless you're running just a really big one. Now, that does lead into one of the newer features they've kind of launched in and around here. So while that one brings online a brand new cluster, to one of the features I mentioned at the beginning, they have something called Backtrack. And Backtrack is something of the same flavor. You have to enable it when you launch it, but effectively what that allows you to do is you can literally kind of roll back your in-place database. So same sort of thing, say Billy just executed a delete statement, and Billy, it happens to be your sysadmin, he says, crap, and he can realize it right then and there. He can hop into the console and quickly just basically undo that, because he can roll the database back to that couple minutes ago before he ran that delete statement, and then the database will start going again from there. Now that's an in place, so again, that's got a little bit different logistics around it, but same sort of functionality of being able to kind of undo something quickly.
And that is very, very powerful again, all driven from the RDS console, no messing around with shell scripts, trying to figure out what's what. I mean, that is a truly powerful feature.
Yep, yeah. So, and like I said, we've used it we haven't used Backtrack as much, but yeah, especially the point-in-time recovery of automated snapshots, it's been wonderful.
So with that, now let's talk about the logistics of increasing your pool or promoting a new master. Sure.
So obviously, when you're running these pools, one of the things will be if you run into a true error scenario, AWS will detect that the master's down, and it'll automatically fail over. However, you still have the ability to kind of manually trigger a failover if you choose. And that allows you to do a number of kind of DevOps maintenance tasks a little bit easier. So take, for example, you decide I want to scale up my database. So we've been running on a T2 small for a number of months, and now it's just reaching the point where we need to go up to a T2 medium. Effectively, what you can do is you can...
And this would be nothing to do with disk space. It's only purely for CPU and memory.
Yep, CPU and memory. And then, so you would just basically say, hey, when I want to add a new reader to my pool, and as part of the creation of a new reader, it's kind of the same deal where you'll go through and say, hey, choose some options, one of those being your instance type. So you'd say, okay, this time I want to launch a T2 medium. It would launch, it would come up and connect to the pool. So now you would have this pool of, say, two T smalls and this new T2 medium. And you could go ahead and launch a couple more of them if you want. But then when you get to the point of saying, okay, I'm now ready for the T2 medium to kind of take over the master, you can trigger a failover and have it fail over to the medium. And then your medium will become the master. And then you can start killing off your smalls. And so you can kind of go through this process of kind of moving them through kind of this failover procedure to get your instances replaced. And that'll cause very small little downtime windows of, like I said, that 60 seconds while it's just doing that failover, as opposed to it being this kind of, oh, well, we need 5, 10, 30 minutes to do this that it would historically be if you were doing this in a non-kind of Aurora RDS setup.
Yeah, and again, all driven through the RDS console. You're not having to mess about with scripts. I mean, it's just, it couldn't be easier on that respect.
Yeah.
So from that perspective, then, you can scale down in the same manner. If you've had some load, you say, right, we've got an influx of maybe a huge amount of data that's being imported and there's going through an awful lot of ETL, etc. Spin up some bigger boxes, allow the CPU to take over, and then, okay, I'm coming back now to a smaller writer because, hey, I'm not doing that right anymore. It's going to be mostly reads from here on in.
Yeah. And so same exact procedure. Just bring on your smaller box, fail over to it, and then start killing off your old boxes once you have your other bigger or smaller boxes in place. Now, when you start talking scaling out's a much easier thing. You don't have to bring failover at that point. It's just a case of just adding more to your pool. If you need to shrink your pool, same sort of thing. You just tell it to delete that particular instance, and then it'll go away. And as long as you're not trying to delete the writer. If you're just deleting readers, there's no issues. It's just kind of
and it's worth noting that with regard to the scaling out, if your application is architected in such a way you've only ever got one reader anyway, in terms of I've only got one client that's reading, then scaling out is not going to make a difference. It's not going to distribute this one select statement across 3 different boxes and aggregate the results. That's not what we're talking about. If you've got, say, for example, got a serverless architecture, you've got Lambda coming in, you've got maybe a period of peak traffic where each Lambda is making a connection out to a read-only box, then yes, that's where distributing your slaves out is going to make a big difference there, because each Lambda will be potentially getting a different server in its pool.
Yeah, and I think one example that we've used this failover beyond just the kind of DevOps scaling up, scaling down, scaling out, that sort of thing. Sometimes, hopefully you never find yourself in this situation, but it does tend to happen. If you're running on some of these burstable instances, right, there is this concept of a credit balance.
Yes, let's talk about that. Now, you've got some fancy graphs to show, don't you?
Yeah, which for those of you just listening at home and not watching, I'll try and describe this as best as I can. Let me just put this up on the screen for those that are watching.
Beautiful.
So effectively,
now you're above me, by the way.
You're just smaller, but you're still over there, so that works out well for me. So as you can see in this example, we have a cluster where there's two databases running, and the reason we can see that is effectively if you were looking at the graphs, you got 2 different lines, one's blue and one's orange, and you can kind of see them going over time. In this particular graph, I'm looking at a 3-day time range. And so originally the orange line was the primary, and we can tell that by the fact that most of the traffic in these lines in the boxes is a lot more pronounced for the orange lines. That was the master for the first 2 days. We can also see that when we look at the CPU credit balance, we started out with roughly 600 credits, and then we started experiencing heavy load on this production database. And when you start experiencing heavy load with a burstable instance, you're going to start eating through your CPU credits.
So what does a credit mean then? What?
So effectively, with burstable instances, you get a base amount of CPU. So just to keep the math kind of simple, let's say on a burstable instance, they allow you to have 10% of the CPU. So as long as you're running at 10% or below, you're not burning credits or you're accruing credits. And so as long as you're staying at that point, you kind of build up this kind of like credit history of saying, okay, well, I've only been using 5%, so I'm accruing credits, and over time you'll have this credit balance. And what that gets you is when your database all of a sudden says, oh, a flood of traffic just came in, I need to now burst up to 20%. Well, you're allowed to do that, but now you're going to start burning down credits. And as long as you still have a credit balance, you stay in the positive. So it's kind of like your bank account, right? As long as you got money there, you can keep withdrawing. You can stay at that higher.
But the difference here is that you'll always be allowed to burst up. It's just determining who's paying for that.
Yes, yeah. And so is it just part of your normal cost, or are you going to have to pay extra because you've kind of depleted your credit balance? Okay, you've overdrawn, so you got to pay some fees.
So the sort of the guideline there is if you're continually burning through your credit balance, then you need to upgrade your instance in the first place, because you've got an app that is clearly using way more CPU than you think you're needing from your burstable.
Yeah, and that's part of you tend to play a lot more with these burstables, especially in the web world with web servers. But it lends itself well for these databases again when you're especially in that development environment, or you're in like a very early production launch where you don't have a whole lot of traffic. They're great because they keep your costs down until you start hitting that point of, all right, now we have enough traffic to justify where we need a more standard instance type where we just get all the CPU all the time.
Yeah, and web applications that have got a distinct traffic pattern. So, classic example is, your users are going away at night.
Mm-hmm. Yeah, because as long as you get that period of lull where you can build back up your credit balance, which if you were seeing these graphs, that's what you'd see. Well, you'd see it more so in terms of it going down, but it started kind of coming back up again. And that's because we had that lull at night where our users dropped off. So we started building up, but we didn't build back up enough of our balance. So the next day when they came back in, we just started trending back down. And so when you find yourself in this scenario where you're on a burstable instance and you're kind of running low on CPU credits, you have a couple of choices at hand. One is you just swallow the fact that you're going to have to pay some extra money that month for the extra credits, or you have to bring online a new machine that has a credit balance. Or if you have an existing one, in this case, where it was the reader hasn't been getting hit as hard this time, so it still has its credit balance. What you can do is then use this kind of failover mechanism, which is what we did. We basically said, hey, we chose our lull point in the morning, which was roughly like 3 or 4 o'clock in the morning, and we failed over, and then all of a sudden we were on a new node that had this full credit balance. And so it gave us that ability to go into the next day to feel confident, okay, we're not going to burn through our credits and incur extra costs. And then the other node at that point becomes the reader, which isn't getting a lot of traffic, so he can start building back up its credit history over time. So yeah, that makes it a very powerful thing, because when you find yourselves in these situations now, when we did that failover, we also released some other stuff that fixed our overall performance issues, which is why we didn't have to kind of keep playing this game of switching back and forth. But you can use this as kind of get you some extra time, right? So if your development team's trying to figure out why are we burning through this CPU, because maybe it's abnormal, maybe it's not a case of it's due to traffic, it's just inefficiencies of some sort, it gets you that ability and the time to say, okay, well, let me fail over to another one that gets me another 2 days of credit to where I can hopefully get the fix deployed out to production without having to bring online these bigger nodes and pay for these bigger nodes in the meantime. So it just gives you that ability to play some more games that you wouldn't historically be able to play.
Yeah, and these graphs are available as part of the default RDS console. It's part of the monitoring tab for each one. And the two you really want to keep an eye on is the credit balance and the free memory. That's going to tell you when you should be looking at the next instance up.
Mm-hmm. Yeah.
For upgrading.
Yeah. And beyond that, the other bits, I've captured the I would say, the main ones here. There's I think a total of 32 different metrics they make available to you that aren't included here. They also include things like, since Aurora, you pay for the database you're using. There's a graph that shows you, okay, what's my current data usage? And you can see that trend over time of, okay, how is my data building up over time? Because
for those of you that loved your MRTG graphs, the green graphs that were a page of everything, that's effectively what you've got here.
Yeah. There's a number one. You can see your network transmit through, are we pumping more data out or taking more data in? Generally, you're going to probably be taking more in than putting out, hopefully, but it all depends on your use case. But yeah, it allows you to start looking at the things, and as you get the kind of historical trend data, it allows your DevOps and developers to kind of start eyeballing and saying, that doesn't quite look right. Because one of the things, if you're looking at this graph, one of the things that was a signal to us that things weren't quite right was our CPU was hovering around 20% normally, and then all of a sudden we just had a huge jump up to where it doubled, and then it just kept kind of staying at that level. And so that was just kind of a red flag for us, because it was it's never done this before. So let's start taking a look and investigating. So when you have this trend information, it allows you to very easily kind of spot with your eye of, oh, this is wrong.
So outside of the graphs, we've also got the classic slow log as well, and we've got our audit log. So you don't lose much visibility outside of being able to shell onto a box and look at the raw CPU and the raw sort of Linux Windows types of metrics. You only get bubbled up what AWS is going to show you here, but in all fairness, what they're showing you is more than enough for you to administer and make decisions based on what you're going to be doing with your instance types.
Yeah, and I mean, honestly, I think the last feature that comes into play here is the performance insights. You don't get to play with performance insights on the burstable instances, sadly. You got to be at least on the R series on upwards. But if you're running with those bigger instances, Performance Insights is another one of those features that kicks in that allows you to start seeing and analyzing your query utilization. So what would normally, I would say, be that historical kind of DBA role of trying to watch the database and kind of find the queries that are causing more load on your database, that's kind of now been bundled into the Performance Insights feature. It gives you these graphs where you can easily quickly go in and see, oh, this particular query or this kind of like series of queries is putting a lot more strain on my database than I thought it was. Let me go check and see, does that query have the proper indexing on it? But it allows you to see that data in real time to where, oh, our CPU just spiked. Let's go look at Performance Insights and kind of see what queries were being executed at that time. And then it even goes to the point of actually kind of providing you those queries. So again, you can easily take that to a MySQL workbench, run and explain, and see, okay, why is this causing so much load on my database?
Yeah.
Very, very handy tool if you're running a database instance size that can have it.
But overall, get you out of the game of having to play with MySQL at a sort of base level or Postgres at a base level, and let you focus your time on getting this done. And while you said it at the front, the actual overall cost isn't that much more than running a normal EC2 instance anyway. I mean, it's not in the magnitudes, because there's no license costs here that are associated with like a SQL Server or an Oracle database, and that's a distinction between RDS versus RDS Aurora. Aurora is this auto-scaling, magical DevOps friendly world versus the sort of traditional RDS where you do have a single server and you manage a little bit more of the replication by hand, particularly for the SQL Server Oracle instances on that side of the fence. But good stuff. Is there any other passing remarks you'd give on Aurora?
No, like I said, we've been using it for a number of years now. Like I said, there's a plethora of cool features that come along with it, and yeah, I generally would approve it, especially if you're missing the likes of a dedicated DevOps resource that kind of really lives and breathes in this world. It gives you a lot of that kind of knowledge and insight without actually having that resource on hand.
Yes, and I would say that where we've had, because we work with a lot of portfolios, we bring sort of the traditional data center type mentality into AWS, and Aurora is one of those services that we always recommend. And what we've discovered is that it's very easy to point to Aurora as being the fault of the slowdown, but in reality, when you dig in through the covers, it's a bad query with poor indexes and poor data structure in the first place, and it's usually not the database that does it. All Aurora does, being in a cloud environment, is just highlight some of those problems a bit quicker.
Yep.
Super. Well, thank you for that, Ryan. I actually miss being with you. It's nice having you in a box. Oh, you're over here now. But I actually think we've talked more now that we're in isolation than we have when we're sharing an office.
Yeah, no, well, I mean, I feel like there's been a lot more web conferences, and when you're in an office, you tend to kind of be able to drown the people out, whereas generally when you're in the web conference, they're on your screen, they're kind of staring you down. Yeah.
Good. Right. Well, thank you very much for this, and we'll speak again.
Sounds good. Have a good one.